welcome to our channel Dawn of Chemistry. Hope you are all happy and healthy in your homes. Stay home, stay safe. In this video, let me explain about the how to find number of isomers possible for a particular compound. How many isomers are, how to find number of possible isomers. Today topic is find number of isomers possible. This is a very important, crucial and confusing topic, and where there is a chance for student immediately commit a mistake because of lack of idea on the question or because of lack of the confidence about the question. They will be wasting time. The major thing is wasting of time will happen in this kind of question. Find number of isomers possible. So in this video I will tell you how to find number of isomers possible for any compound in a systematic way, so you can do this problem in very less time. In exam also there will be no further confuse for you people. If you are new to this channel, subscribe to the channel and click bell icon for the more updates, and don't forget to like the video and share the video. Let's get into the details. Find number of isomers possible. Whenever you are finding number of isomers possible, let me tell you one question how they will ask means C4 H10O. Find how many isomers possible. So C4 H10O they gave you, find how many isomers are possible. Another thing is C8 H10. C8 H10. How many isomers are possible? How many isomers are possible? So this kind of questions they will be giving you. Then how to do this problem? So let us see the first thing. To identify number of isomers possible, first you should have idea on the isomerism completely. Let me tell you briefing of this isomerism. I have made separate videos on this isomerism thing, but let me give you the brief idea so you will understand the better concept. So see, basically isomerism is structural isomerism, stereo isomerism. The structural isomerism is chain isomerism, position isomerism, metamerism, tautomerism, and functional group isomerism. So these are the different isomers which are possible for the structural isomers. Coming to the stereo isomerism. Conformational isomerism, configurational isomerism, conformational isomerism, and then configurational isomerism. This configurational isomerism is two types, that is geometrical isomerism and then optical isomerism. I will explain everything in detail in separate videos, but let me brief the things here. So whenever they ask you find number of isomers possible for any compound, first you should have idea on what is isomerism and how many types of isomers are possible for any compound. So basically isomerism is structural isomerism and then stereoisomerism. In the structural isomerism, chain, positional, meta. Of course, meta is a kind of a positional isomerism. Tautomerism and then functional group isomerism is present. And the stereoisomerism, conformational isomerism and configurational isomerism. The configurational isomerism is geometrical isomerism and then optical isomerism. Let me make one point very clear. Whenever they are asking you find the isomers, you have to find how many chain isomers are possible, how many positional isomers are possible. Tautomerism, no need to apply. You have to identify how many functional group isomers are possible. Conformational isomers, no need to calculate. You have to find how many geometrical isomers are possible, and you have to find how many optical isomers are possible. You have to club all these things. Number of isomers is equals to chain isomers plus positional isomers plus functional isomers plus geometrical isomers plus optical isomers. Or they will ask you number of structural isomers. Number of structural isomers means geometrical isomers plus positional isomers plus functional isomers. Number of stereoisomers. Number of stereoisomers is equals to geometrical isomers plus chain isomers. Number of geometrical isomers plus number of optical isomers will come. How to find number of geometrical isomers and optical isomers also I will explain in a separate video. For this video, when they give you the formula how to find number of isomers, that much we will see. Right. Now let us see, this is the basic thing you should know before finding number of isomers possible for a compound. Let us see how to find isomers for these two things. The procedure is the very first you have to do is, the first thing is find functional group present in formula. Find functional group present in the formula. We know very well general formulas are there for different compounds. If there is alkanes, when alkanes are there, CnH2n plus 2. Alkenes are present means CnH2n will come. Alkynes are present means CnH2n minus 2 will come. Alcohols are there. Alcohols are present means CnH2n plus 1 OH. That means CnH2n plus 2 O will come. And aldehydes are ketones. Aldehydes are ketones. Aldehydes are ketones means Cn H2n O will come. CnH2n because in presence of two hydrogens one oxygen will come. That's why CnH2n will come. In case of carboxylic acids, in place of carboxylic acids it will be CnH2n O2 will be coming. If you take CH3 COOH, you can compare like this. 2 are there and this is 4 are there and 2 are present. Like this we can identify the different compounds and their molecular formula. So alkanes are present means alkenes, alkynes, alcohols, aldehydes and then carboxylic are there. And cyanides are present means CN H2n minus 1 n will come. Cn H2n minus 1 n will come. When there is amines are present, Cn H2n plus 1 n will be come. Like this, these are the major functional groups present in a compound. So the very first thing what you have to do is you have to find the functional group present in the compound. This one I will explain after this. So the first thing you have to do is find the functional group present in the compound. That is the first step. Whenever they give you any formula and they ask you find number of isomers possible, means the very first thing you have to do is you have to find the functional group present in the compound. These are the general formulas of the different compounds. Next you see, after finding this, the second one is finding functional group, write possible functional isomers. So after finding functional group in that, write possible functional isomers. So here you see C4H10O. C4H10O is in the form of CnH2n plus 2O. So that's why it is alcohol. You know very well alcohols will have two functional groups, that is alcohols and ethers. Two functional groups are there, alcohols and then ethers. Now what you have to do means, after finding right functional isomers they are asking. So C4H10O means you can have alcohol, you can have this ether. So we have written the possible functional isomers. The next thing is write chain isomers. Write chain isomers for every functional group. Write chain isomers for every functional group. So they have given you alcohols and ethers, they gave you. For every alcohol and ether you have to write the chain isomers. Hope you have taken this thing. So I am rubbing this one. So you have written alcohols on this side, ethers on this side. Now let us write the functional isomers possible. So here alcohol is there, chain isomers OH, and this one is there OCH3. Here you see 4 carbons are present, so that is one chain, and here 3 carbons are there, that is one chain. 2 carbon chain is not possible. Here methoxyethane is there and then ethoxyethane is present. So here main chain is having 4 carbon atoms, here main chain is having 3 carbon atoms. Here main chain is having 3 carbon atoms, here main chain is having 3 carbon atoms. 1, 2, 3, 4 are there, so OH is there. Here 1, 2, 3 is there, so that's why 3. For 2 it is not possible to write. If you write like that also, some complications will come. If you see with the 2 mains, how you will write 1, 2 are there, OH. You write like this also, again it will become a 3-membered thing will come. So that's why we can't write further. So write the chain isomers possible. After this, next thing is write all possible positional isomers for every chain isomer. Write write all possible positional isomers for every chain isomer. So here this is one chain, so that's why one butanol will come. You can write it as 2 butanol. So this is 1 butanol and this is 2 butanol. And for this one, 2 methyl 1 hydroxy propane will come. After this, 2 methyl 2 hydroxy propane will come. This is 1 propanol and this is 2 propanol. If you want to change the functional group into this thing, means it will become 2 butanol. So it is not possible. And this one you see, methoxypropane. This is 1 methoxypropane, this is 2 methoxypropane will come. And this one, ethoxyethane, it will be as it is because further it can't have any chain isomer. So like this you can identify the possible isomers. Up to here structural isomers are over. Up to here structural isomers are over. So first identify the functional group present in the compound. After identifying functional groups present in the compound, write possible functional isomers for the compound. What are the functional isomers means I will explain after this thing immediately. So after this thing, after finding this, you have to write the chain isomers possible. For every functional isomer, you have to write the chain isomers possible. After writing chain isomers possible, you have to write the positional isomers for every chain isomer. With this, you can completely do the structural isomers possible. After structural isomers, how to find the geometrical isomers and optical isomers. How to find the geometrical isomers and then optical isomers means, have a look on this. Fine, I am rubbing this. So see, now we have written C4H10O. The possible isomers we have written is 1 butanol is present, 2 butanol is present, 1 propanol, 2 methyl 1 propanol is there, 2 methyl 2 propanol is present, methoxypropane is present, 2 methoxypropane is present, ethoxyethane is present. The next thing is finding number of GI. Finding number of GI. For these things, separate formulas are there. For finding number of geometrical isomers, number of double bonds needed. Number of double bonds is required. If number of double bonds is n, both ends are different. When both ends are different, number of isomers is equals to GI. Number of GI, both ends are different means 2 power n will come. So if you take this compound, this side methyl ending is there, here ethyl ending is there, so both are different, so number of GIs is equals to 2 power n. And if both ends are same, if both ends are same, then if n is odd, 2 power n minus 1 plus 2 power n plus 1 by 2 minus 1 will come. Two power n minus 1 plus 2 power n plus 1 by 2 minus 1 will come. Means you can take this example. This one. Both ends are, this is having methyl group and this is having methyl group. Now you see, both ends are same. Here it is having chloro group, here it is having chloro. 1, 2, 3, 4, 5 are there. Then you have to use the formula. If both ends are same, n is odd, then 2 power n minus 1 plus 2 power n plus 1 by 2 minus 1 will come. If n is even, then number of Gi is equals to 2 power n minus 1 plus 2 power n by 2 minus 1. This one you see, both ends are having methyl groups, 1, 2, 3, 4 double bonds are there like this. We can find the number of geometrical isomers. So number of geometrical isomers depends on the number of double bonds. If they are cyclo compounds, it's a different scenario, but that much complication, there is no chance to go there. So that's why for open chain only, I am telling you here. So number of geometrical isomers equals to, that depends on number of double bonds. If number of double bonds is n and both ends are different, here methyl substitution is there, here ethyl substitution. So 2 power 3, that is 8 geometrical isomers are possible for this compound. And here you see, if both ends are same, here also chlorine, here also chlorine, 1, 2, 3, 4, 5. When it is odd means you can take 2 power 4. 2 power 5 minus 1 means 2 power 4 plus 2 power 5 plus 1 by 2 means 3 will come. 3 minus 1 means 2 will come. So 2 power 4 and 2 power 2. What will be coming means 2 power 4 means 16 plus 4, 20 isomers are possible. If not means it will be 2 power 5 will come. So that's why a different number will be coming. 32 would be coming, but originally here it is coming 20. And here you see, if n is even, when n is even, you can use this formula. Here 1, 2, 3, 4, both ends are same. So that's why it will be 2 power 3 plus 2 power n by 2 minus 1. So n by 2 minus 1 means 2 power 1 means 2 power 1 will come. 8 plus 2, 10 geometrical isomers are possible. Like this, you can identify the number of geometrical isomers possible for any compound. So to find the number of isomers, you should know the double bonds for this thing. But here you see, is there any double bond possible in this case? Means there is no double bond. So that's why geometrical isomers are not possible. This is very important thing, how to find the number of geometrical isomers possible for a compound. So based on number of double bonds, you can count it. If they are spiro compound or not spiro, cyclic compounds are there, for them that is a different scenario. Here we will not discuss about that. So geometrical isomers are not possible for the given compound. So that's why you can keep it aside. And after this, let us see optical isomers possible. Remember this carefully. The same is possible in this case. In place of geometrical isomers, I am writing number of optical isomers. To find number of optical isomers, in place of double bonds, you have to use chiral carbons. Chiral carbons. What is this chiral carbon means? Carbon attached to 4 different groups or 4 different groups only you can take. Substituent means it goes in a different way. So carbon attached to the 4 different groups is known as a chiral carbon. So based on chiral carbon, we can find this thing. Number of optical isomers means same formulas will come, but the examples will be different. Let me tell you this thing. Number of optical isomers. If any compound is having number of chiral carbons is n, if both ends are different, means let us take this example. OH, Cl and H2. In this case, you see this carbon is attached to methyl group, amino group. This is a bulky group and hydrogen. So this is a chiral carbon. Here this chlorine is present, which is attached to one side chlorine, one side C2H5OH, one side this one, and one side hydrogen. So this is a chiral carbon, and in this case OH is there, methyl, OH and bulky group. So this is a chiral carbon. So 2 power 3 means 8 optical isomers are possible for this thing. If both ends are same, OH, OH, OH and OH will come. OH. So here you see we need odd ones, right? So that's why what I will do means OH. So now you see this compound I am taking, if both ends are same, here ending methyl is present and ending methyl is there, instead of both ends are same, you can write plane of symmetry. You can write plane of symmetry means if you put any plane means you can divide that into 2 equal halves. Then it is known as a plane of symmetry. So let us take this compound only. I will explain how. I will write OH on this thing. So in this case you can see plane of symmetry is possible. If you put a plane like this, you can divide this into 2 equal halves will be coming. Here methyl is present, 1, 2, 3 are there, and here you can have a plane. Exactly, you can divide this into 2 equal halves. Here you can draw a plane on this thing. So you can have 2 equal halves on this thing. Exactly on this point. Once you elaborate this compound means 2, 3, 4, 5, 6, 7 are there. So 2, 3, 4, 5 CH3, CH3, OH, 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 OH and OH are there. So now this kind of things are present when there is a plane of symmetry. Here you can draw a plane, so which will be equally divided, and N is odd. Chiral carbons are odd means this is one chiral carbon, this is one chiral carbon, this is one chiral carbon, and this is one. In this case 5 chiral centers are there. 1, 2, 3, 4, 5 are there, and there is a plane of symmetry. So in this kind of compounds you have to use this formula, so you will get the 20 optical isomers. And finally you see this thing. For this example you can take is, we are looking for 4, so that's why 1, 2, 3, 4. Both ends are same, so the compound is like OH, OH, OH and OH, CH3 and CH3. Here you have plane of symmetry. That means if you can equally divide that into 2 equal halves, you can take If n is even, then this is the formula. So number of geometrical isomers possible will be 10 for this compound. Like this, we can find the number of geometrical isomers and number of optical isomers by using this formula very simply. So be careful with this thing. Now let us move to the next thing. In this case, how to find out the isomers means. See, in this case, any chiral carbon is there with no chiral carbon. Here also no chiral carbon. Here one chiral carbon is there. You see, this is the carbon which is having one hydroxy group, one methyl group, and one ethyl group is present. So that's why for this two isomers are possible. And this is having no chiral carbon, no chiral carbon. This one no chiral carbon. This is also no chiral carbon. So that's why how many isomers are possible means number of isomers is equals to 1, 2, 3, 4, 5, 6, 7, 8. Number of isomers possible is 8 for this compound. Like this, we can find the total isomers possible. If they ask you how many structural isomers are possible means 1, 2, 3, 4, 5, 6, 7. How many isomers are possible means you have to include the structural isomers, optical isomers also. So like this you can do the problems. And next problem I have given you is like this. Whenever they ask you find number of isomers possible means you have to club everything. Now let us see. They have given you a compound already like this, C8H. So whenever the carbon and hydrogen atoms are very close to one another, definitely there will be benzene ring. There will be benzene ring when number of carbon atoms and hydrogen atoms are same. That's why you can have a benzene ring on this. CH3 will be CH3. So you know very well when two substituents are there, you can have the three isomers, that is ortho, meta, and then para isomer. So that's why you can write ortho isomer and then meta isomer and then a para isomer. Any chain isomer you can have means, yes, you can have a chain isomer also, that is nothing but the CH2, CH3. Like this, you can write the number of isomers possible for this compound. In aromatic compounds, you have to see the functional group present in them. After that, chain isomers. After that, positional isomers we will be writing. And you can write open chain structure also for this compound like this. C, 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 C. 1, 2, 3, 4, 5, 6, 7, 8 will come. You can put triple bonds between them. Triple bond. Here you can write CH3. Here you can write CH3. But the remaining 3, 3, 6 are over. So you can put 4 hydrogens somewhere. So one hydrogen, other hydrogen here, another hydrogen here. Like this, you can write open chain structure also. But this leads to the so many structures are possible. Since this is having triple bonds and double bonds between them, you can write number of positional isomers, and also that's why that leads to the so many complications. So that's why they will not ask this kind of questions when they give you the aromatic compound. They will ask you how many aromatic isomers are possible. So be careful with this kind of questions. If you write answer in this way means definitely your time will be wasted. That's why they will not ask this kind of question. And one more thing I will explain. With that problem I will close this thing. Let us say find number of isomers possible for C4 H8O2. C4H8O2, how many isomers are possible for this thing? We know very well C4H8O2 means it is in the form of CnH2nO2. CnH2nO2 means it is carboxylic acid. First point is write the functional isomers. Carboxylic acid functional isomers will be carboxylic acid is present, ester is present, these two are the functional groups. Along with them aldehyde alcohol is present, keto alcohol is present, aldehyde alcohol is present and keto alcohol is present, alkene alcohol is present, ethers are present. In every case you can have ethers also. Among these alcohols are there and then ethers are possible and then cyclic diols are possible and then cyclic ethers are possible. This many functional isomers are present. So that's why what you can write for this thing means C4H8O2 means CH3, CH2, CH2, COOH. You can write CH3, CH2, C double bond O, CH3 will come. You can write CHO, CH2, CH2, CH2OH, CH3, C double bond O, CH2, CH2OH. Alkene alcohol, not alkene diols are possible. And alkene diols means CH2 double bond CH, CHOH, CH2OH will come. Alkene diols will come. Alkene diols will come. So aldehyde alcohol is there, ketone alcohol is there, alkene diols are there and ethers also possible. CHO, CH2O, CH2, CH3. CH3, C double bond O, CH2O, CH3 will come. And cyclic diols also possible. OH and then OH will come. Number of carbon atoms is 4. Hydrogens will be 1, 2, 3, 4, 5, 6, 7, 8 will come. Like this number of compounds you can have. And you can have ethers also. This also you can have. Like this number of compounds are possible. So always remember, whenever they give you carboxylic acid, this many isomers you can write. And further, for every compound you can write positional, you can write chain isomers, and you can go for the optical isomers. So the number will be very, very high. Like this, for every functional group, certain functional groups isomers are possible. That also you should be very careful about. I will make a different video on this thing. So like this we can study about the number of isomers possible. Like this, let them give you any compound, you can find number of isomers very easily. And one more important type question they can ask you is, after monohalogenation, how many isomers are possible? That kind of questions also very, very important. I will explain that thing in a different video. Hope you enjoyed this video. Try to subscribe to the channel, and for more updates click the bell icon. Don't forget to like the video and then share the video. Thank you.